Yes, welcome all. This is Dr. D. VEMANA CHARY, Professor, EC Department, Tigala Krishna Reddy Engineering College. Now we are going to discuss the topic about Internet of Things. So Internet of Things means Internet of Things connected to everywhere. So everything should be connected to the Internet. So what is Internet of Things? Now we are going to discuss. So what are the effect of this Internet of Things, how it change the enabling technologies, evolution of these advanced technologies related to Internet of Things. Now we are going to see now. The Internet of Things here is physical objects are everything, things, and nowadays, so in 2024, everything is connected to the internet. So suppose any device, if you want to connect to the net, so that should be the electronics, sensors, network connectivity, and we have to connect to the cloud. So to connect the Internet of Things, things made up of with the sensors. Sensors are nothing but it may be the since the physical parameters. What are the physical parameters? It may be humidity, it may be smoke, it may be temperature, it may be the firing. So everything physical parameters can be analyzed, and those can be the physical parameters can be connected to the electrical signal. So these sensors sent to the processor. So this is the basic function of the sensor. Sensor receive the data from surroundings and it sends the data and send to the processor. This is the basic function of the IoT. So now in IoT system, so after processing the data, first data can be stored. Where we have to store the data? To store the data, it requires very big memory size. To store this data, we require very large servers. So those servers in the range of exabytes of data. So Internet of Things, whatever data, surrounding data, they can capture the data and without process the data, directly they can send to the server system. So whenever the sensor, whatever they are sensing the data, receiving the data, if they directly transfer the data to the cloud system or server system, so what happens? So how much servers, what may be the big size of the servers, the data we can't store the data because it is the very large amount of data. To avoid that one, before processing the data, we are using the filters. So that filters are nothing but, so whatever sends the data, when it has to send the data, which data it has to send, what is the range of data, whether it should be required by the user or it required by the application. Depends on the application, we can transfer the data. So due to that reason, we can save the system memory space, buffer size, network connectivity, network latency, these things. Just we can see here where this is Internet of Things. So Internet of Things should be the everywhere. So it should be in industrial, it should be in infrastructure, in VMware, research, trans systems, automobile industry, home automation, surveillance system, weather monitoring system, enterprises. So everywhere we are using the Internet of Things. So in transportation, so if you know the position of our goods, position of our vehicle, we are, through the Internet of Things, we can easily identification the location of current status. In industrial application, whether all systems are working in proper way or not. So whether any fire is occurring or not, any gases are leaking or not. So we can easily identify using this Internet of Things. In industrial applications, in healthcare and life sciences, so everywhere we are using the Internet of Things. So these things we can divide as devices. Device, it can be connected through the devices, fire system, public places, food places, power systems, MPS, pumps, traffic signals, and location depends on the application. We can divide the location. So where it may be the location office, it may be the education, it may be the healthcare system, it may be the services or e-commerce. So it may be the restaurants. So everything we can connect the this look, we have to identify the location. Which type of application groups, so we are using this Internet of Things means in industrial, in infrastructure, air systems, transfer systems, vehicles, stores, hospitals, enterprises. We are using these type of different application groups. Next, in which service sectors we are using this Internet of Things? In service sectors, in transportation, we are using, in healthcare systems, we are using, in IT sector, we are using, retail system, we are using, energy research systems, we are using, it may be solar energy, it may be the electric energy, it may be the biogas energy, and building infrastructures, home appliances, we are using this Internet of Things. Everywhere we are using this Internet of Things. So now, how about this Internet of Things? So it may be the small processing unit. It requires less memory power. It requires less power. It has a just computer, but it is the very less complicated computer. So it can be connected to the billion of devices. It can uses the frequency band. It uses the only narrow band frequency band. That means it never disturb the normal functionality of the all radio frequency signals. So those are the, it doesn't affect the RF band, RF spectrum. That means it doesn't affect the TV broadcasting, FM broadcasting, so this networking broadcasting, Airtel or Idea or Geo, everything, it doesn't affect the any system. It requires very little bit frequency band. Due to that reason, it utilizes the narrow band frequency system and it uses the industrial, scientific, medical frequency band. That is the free of cost, we can use that frequency band. So it never affect any other radio spectrum or it never bandage with other radio frequency system. So if you go to the Internet of Things, so everything is connected. So it has to capture the data. Whatever it is capturing the data, it can transfer the data to the nearest aggregate node through the internet, through the Wi-Fi system or Bluetooth system, Zigbee system. After receiving the data from this device, that aggregate node or fog system, fog node, it can connect it through the internet. It processes the data to the cloud system or server system. So whenever we are using, this distance should be the range of 100 meters. So these circumstances to the these sensors, these things, they can receive the data from so in range of centimeters, so range of meters only. So after receiving the data, they can send the data to the using wireless technologies. It may be the Bluetooth technology, it may be Wi-Fi technology, maybe Zigbee technology. So it can transfer the data to the aggregate node or cluster node. After receiving the data from neighboring nodes, that aggregate node or cluster node. So depends on the application, depends on the demand situation. So it has to decide which data it has to transfer, which data it has to remove. So this aggregate net filters the data. Only filtered data can be transferred to the server system. So why we have to filter the data? Without filtering the data, so we can't analyze the data. By filtering the data, we can easily analyze the data. We can whatever data we require, that easily we can retrieve the data from the cloud system. So this here we can connect the things. It may be a cars, it may be the smart homes, it may be the automobile industry. So it may be the hospitals. So wherever we want to connect, we can connect the things. But we have to choose how much lifetime of these things. So this lifetime of the things can vary to the weeks to the years. So it depends on application, it comes in the data. Once you establish the infrastructure, Internet of Things, so only you have to receive the data from those things. So now you have to collect the data. That means to establish this network, the Internet of Things, this low cost expenditure process. Things highly constraints in nodes in terms of physical size, CPU power, memory, bandwidth. Already we discussed about the bandwidth. It uses the very low bandwidth. So it can process the lower data speeds only. Power consumption. Power consumption should be the we have to take care about very critical. So by utilizing less power only, it has to process the data. Whenever it doesn't process the data, in which situations there is no need to take the data. In that case, we have to keep the node or we have to keep the sensor in sleep mode because to make the power for increase the lifetime of the specific sensor or specific Internet of Thing. So we have to take care about central processing unit power. So central processing unit power, by utilizing the power ranges from 3.5 volts to maximum of 12 volts. By utilizing this power, it can easily process the data to the, it has to capture the data, it has to process the data. So depends on application, we can design the physical size. Suppose in forest, to monitor the greenery of the forest, to maintain the, to monitor the fire occurrence of the forest. So once we distribute the thousands of sensors in the forest, out of thousands of the sensor, some of sensors, they can't be in dead mode. They can't be utilized. Only we can utilize the data by using out of 80% of sensors. 90% of sensors. Suppose if you distribute the 15,000 sensors in a forest, out of 15,000 sensors, so if the 14,000 sensor or 40,000 to 500 sensors are in come to the working condition, that is the good enough. Just we have to. So if you don't receive the data from remaining 10% the sensors, so that is not a matter. So we can monitor the forest. So all sensor come to the in working condition. They have to capture the data. They have to maintain the take the data. They can always give the data to the status of the greenery of the forest. So, and whether they can sense the any smoke is there, any carbon dioxide is there. So immediately they can transfer the data to the aggregate node. After receiving the aggregate node at the forest monitoring station, forest server system, it has to maintain that one. There should be something is different to this normal operation. Immediately they can monitor, they can verify the location of the sensor, they can verify that one. So they can easily, if there is any fire is occurred, immediately they can found and they can avoid the firing occurred in the forest. So without this Internet of Things to monitor the forest, the range of thousands of kilometers of forest, to maintain the greenery of the forest, to find out the firing in forest, that is the difficult process. Nowadays, that is easy to find the forest whether any fire is occurrence or not. So in health monitoring system also, by completely we can monitor the health condition of the patient by using Internet of Things, by connecting the all sensor, ECG sensor, pulse sensor, BP sensor, like that. If you see this one, how this can be the working of this Internet of Things. So this Internet of Things, so it may be the small computer, small processing unit. Small processing unit, it has the sensor, it has the processing unit, it has the some storage device, it is having the transceiver. It can transmit the data and it can receive the data. So communication and cooperation, whenever anything or any sensor process the data, it consume the less power. Whenever it transmit the power, it requires more power. So to identify the location of the any sensor, so it requires the to easily monitor the location of the sensors, we have to give the address. So which type of addressing we are giving? We are giving the unique address for the sensor. For universal wide single address. That address is never matched with the another device in the world. So only each device having unique address, universal identification number. So by using this one, whenever we are not in the server system, enter the world. So by sensing that one, receiving that data, we can easily identify the from which region, which location we are getting the data. So for that one, we require some sensors, some processing unit, some storage memory and transceivers. So this is the working of the IoT thing, Internet of Thing. So we have to design the this Internet of Things depends on our application, whether we have to increase the storage power or decrease the storage power, whether we have to design the this processing unit with less capability or more capability, depends on the application we are designing. Suppose, for example, so we have to only receive the temperature. We have to monitor the temperature. For that one, we require less physical size of sensor. So it may be in the range of within centimeters range of the sensors we require. Suppose master sensors, they require, they occupy the less space, and so they require the less memory power, less processing units. Depends on application, we are decide the this size and processing speed of the things. In these sensors, so where we can use, we are using these things in RFIDs, radio frequency identification and sensors, in smart technology, in industries, in nanotechnologies, we are using this Internet of Things. And suppose if, for example, if we take the radio frequency identification, where we can use this one, wherever there require the, doesn't require the active power, that depends on the indirect power. In that case, we are using RFIDs. So RFIDs, they are taking the energy from whenever they are near to the receiver, then only from, due to the magnetic flux, they are receiving the energy and they are activated, and they can give the data to the this receiver system. So in sensors, so whatever changes in the surroundings, they can capture the physical data in analog form, and they can convert to the electrical signal, and they can process to the this form system. Is smart technology, smart IT technology. So wherever in different part of the network, whether it may be the mode process at the node level, at the fog level, so where in the cloud level or at the big data analytics level, depends on the application, we can use the sensors, Internet of Things. In nanotechnology, in very, very small things, and small things, they have to be used in the fabrication systems. So they occupy the in the range of very, very little space, and they can transfer the data to the server system. So these are the different type of technologies we are using for Internet of Things. So what do you mean by smart device? Smart device, it may be the electronic device that can operate and very actively and very sensitively, and it should be very sensitive to the surrounding effects. Whatever effect it may be, so it can easily catch the changes of the surrounding parameters, and they can send to the system. This is the, it should be the very smart and active devices. So now, what do you mean by smart? Smart should be the intelligence, interconnect, uh, sensor. Sensor, smart should be the sensor should be with the connected to the server system. It should be the fast response to the surrounding effects, surrounding changes of physical parameters, and they can find the changes in very quickly and very deliberatively and very fastly, and they can process with, they can utilize the less frequency band and very fast speed. So where we can use this smart. So what are the, what do you mean by smart? Those can be very fast to respond to the surroundings. Those are called the smart devices or smart equipment. What are the examples of these smart devices? Smart factories, smart home, smart cars, smart cities. That means whatever may be the happen in the thing. So it may be any another person entered the city, so any terrorist activities. So they can be identified by using the image sensors. So they can be identified at the railway stations, bus stations, aerodromes. They can easily identify these different type of persons and they can monitor those systems. We can easily find the any unauthorized activities. So this is the smart activities, smart homes, smart cities, smart technologies. So by using this Internet of Things, we can give support to the sustainable things, sustainable development things. We can give support by using Internet of Things. So now, whenever we are passing the data, so what is the there should be the common protocol structure for the complete group. What is that is nothing but IoT World Forum reference mode. So in normal computer networks, we are using OSI model, Open System Interconnect model. In the same way, for Internet of Things, we are using the IoT World Forum reference model. So in that model, it should be the similar to the OSI model, just should be the little bit different to that OSI model. So here first layer is physical layer that should be related to the physical devices and controllers, sensors, machines. In second layer is connectivity layer. Third one should be the edge or fog computing. Fourth one should be the data accumulation, that means to store the data. So fifth one should be the data abstraction, data aggregation, data filtering, data removing. So sixth one should be the application level to analyze the data, to monitor the data. Seventh one to distribute the data, which to whom we have to, which user we have to supply the data, which user requires this data. This is the IoT World Forum reference model. Example of IWF reference model. See this one, devices are connected to the network. So network should be connected to the edge computing. Edge computing, they can remove the unwanted data and whatever required data, that only process to the data storage system, server systems. Thereafter, after receiving data, which data has to be utilized, which data required. So that can be the abstract the data. After receiving the data, structured data and unstructured data. They can receive the structured data, they can receive the data from structured data, and they can receive the data from unstructured data. They can send to the different applications. But using this different application, where we can use, whether we can use in the hospitals, in agriculture, in smart worlds, in industries, depends on the application we can use this data. So if you see the layers of the IoT system, so these are the three layers: perceptual layer, network layer, application layer. So this network layer is defined as the, again, due to the IEEE standards, object abstraction, service management, application layer, and business layer. Depends on the data we are having, that can be utilized for the which user require the data, which user, which type of the data they require. We can send the data to the, provide the data to the business layer. That can be the consider of the business layer. So now if you see the protocol architecture of the IoT, so this is the protocol architecture of the IoT, which layers data can be the processed. First, physical devices, controllers, thus can be the handled by the edge systems, connectivity, edge computing. So after receiving the data, this can be processed, aggregated, and data accumulation. Next, data abstraction, desired data only, we can store the data, remaining data can be removed. So it depends on the application, we can transfer the data. So these mainly we can divide as a three layers: infrastructure protocols, service discovery protocols, application protocols. So ways to easily process the data, to attract the more users, to provide the more data. So we divide as the only three layers: infrastructure protocols layer, service discovery protocol layer, and application protocol layer. So now if we see the categories of the protocols, which network technologies we are using? We are using the Z-Wave, Bluetooth, low power band. Network players are IPv4, IPv6. So IPv6 give the many devices. IPv4 is restricted device because the number of devices should be limited. Whereas IPv6 unlimited, it gives address for the unlimited devices. So now internet protocols we are using TCP, UDP protocols. If we see the application protocols, we are using COEP protocol, MQTT protocol. MQTT protocol is message queue transfer protocol. So this telemetry transfer protocol it can transfer the less data with the utilizing the narrow bandwidth with higher speeds. So these are the different technologies we are using to support these protocols. We can support to the emerging technologies. To connect the any IoT elements, so we are using any devices, they can be connected to the Ethernet, they can connect through the Wi-Fi, they can be connected by using the Bluetooth technology, they can connect Zigbee technology, they can connect. For gateways, we are using the internet protocols. After connecting the gateways protocols, we are using the service discovery protocols. Those service discovery protocols are TCP and UDP protocols. Next, HTTP protocol, web protocol, application web transfer protocols. These are used for the application layers. If you see the communication IoT protocol stuff, so it can be the physical layer, data layer. So at the sender system, data can be